Picture this, you step into a machine and bam, you are in the year 3025, or better yet, you are chilling with dinosaurs 65 million years back. Sounds like a straight up science fictional, right? But here's the wild part. Real science actually says time travel could be possible, at least in certain ways. Now, today on Space from Rohit, we are digging into the universe's biggest question: is time travel real or just a fantasy? So let's roll. Now, what is time really? Before we even talk about time travel, we gotta ask, what the heck is this time anyway? It feels like this river always pushing forward, but in physics, time is a dimension, just like space. Einstein showed us that space and time are linked together, and that's space time. Think of space as a map and time as the road you are driving on. And like any road, maybe you can flip a U turn. Now, relativity, time travel to the future. Here's the cool part: science already says traveling to the future is legit. Einstein's relativity shows that time moves differently based on speed and gravity. The faster you move, the slower clock ticks. The closer you are to something massive, the more time stretches. That's time dilation. Example: astronauts on the International Space Station age just a tiny bit slower than us on Earth. Now, push that idea. If you cruise close to a light speed, a year for you could equal to 100 years back home. Boom, you are officially a future traveler. Now, black holes and time distortion. Well, black holes don't just gobble up matter, they mess with time like crazy. Near the event horizon, time almost freezes compared to fogs far away. Interstellar nailed this. 1 hour on that water planet near a black hole, and that's equal to 7 years outside. So, yeah, black holes are basically natural time machines, but only into the future. Heading to the past, though, that's where things get messy. Now, time travel to the past. Is it possible? Well, Einstein's math doesn't totally block it. That's this idea called a closed timeline curve. Basically, a loop in a space-time that drops you back before you left. Sounds dope, but also screams paradox alert. Still, relativity doesn't shut it down. Now, here's the interesting part: the grandpa paradox and consistency. Well, you have heard this one, the grandfather paradox. Go back, stop your grandpa from meeting your grandma, and then you are never born. But if you are never born, who went back? One solution is the Novikov self-consistency principle. Whatever you do in the past, the universe won't let you break reality. You try, you fail, end of story. Or maybe alternate timelines. Change the past and boom, you are in a fresh branch of reality. Now, wormholes, your best time machine. Well, wormholes are like shortcuts through space-time. Two doors connecting faraway places and possibly different times. If one end of the wormhole zips around at near light speed, you could step through and pop out years earlier or later. The catch? They need exotic matter to stay open. And we haven't found that yet. But the math checks out. Now, quantum mechanics, time's hidden tricks. Now, quantum physics, oh boy, it makes things even weirder. The many worlds theory says every outcome spawns a new universe. Flip a coin, heads in one world, tails in another. Maybe time travel just hops you between these universes. Other ideas hint at retrocausality, future events nudging the past, which sounds insane. But hey, quantum physics doesn't care what sounds insane. So we can time travel to the future? Heck yeah, physics says so. To the past, maybe wormholes, black holes, quantum timelines, they all give us hope, even if we are not there yet. Bottom line, the universe doesn't forbid time travel. It just makes it ridiculously hard. So, smash that like button, subscribe and drop a comment. If you could time travel, Where would you go, past or future? Stay curious, my friends, because the greatest trip might not be across space, but across time.